Good morning, good afternoon, good evening, wherever you're hailing from. Welcome to another episode of Ask an OpenShift Admin. I am joined today by Andrew Sullivan, the host with the most, I will say today. How about that?
Wow, throwing me a curve there. So
Trying to come up with friendly names for everybody. How about that?
Well, long time no see. It's been what, two weeks, 3 weeks, something like that.
I had a procedure on my neck, and that went well. And then I went on vacation to kind of have some fun and then recover in the same time. So that was all very, very nice.
The stream was away for a little bit. We were gone for Summit. If you missed Summit, it was a virtual event, a free virtual event. So if you happen to miss that, be sure to register, check out all the content. There's hundreds of sessions, including I co-hosted an Ask the Experts. So you can always come and see us there as well. And then last week, our apologies. We just had some technical difficulties where the audio just would not cooperate. So about 20 minutes in, we just decided to pull the plug and canceled last week's episode. But it worked out because that means that our guest, who is Brian Baudwin on our consulting team, I think, is able to join us this week. He wasn't able to join us last week. So, Brian, if you don't mind introducing yourself.
Thank you. I'm Brian Baudwin. I work with the technology practices at Red Hat, specializing in OpenShift, and currently a principal consultant. I've got several clients, currently mostly in FSI, financial services industry. And OpenShift is pretty much what I work, live, breathe, eat. Try to eat a little better than that, but
well, I gotta say, I'm feeling a little jealous today between you and Chris and your rig setups there with the cameras and audio and everything else, and your beard is just absolutely majestic.
Yes,
I'm failing on multiple fronts today. So,
as someone who can't grow a beard, I am definitely envying yours, Brian.
Yeah.
So,
well, thank you.
Anyways, thank you very much for joining us today. Really happy to have you here to talk about, if you have seen the show title, certificates in OpenShift. And it's funny to me because as we were going through and I was doing all the prep for this show, and I have a document that I use to keep organized with like the show title and the abstract, and Brian was very helpfully going through and correcting, like, no, we don't do this. This is the wrong term. And I'm like, that's exactly what I want. You are like, that just means to me that you are the perfect person to have on this show. So don't at all feel bad for being like, no, Sully, you're wrong. Shut your mouth. That's exactly what we want.
Yeah. Don't feel bad about questioning the host.
Yeah.
Don't feel bad about that at all.
Especially not me.
My comment was internally screaming. SSL is a bit of a dated term. I'll just go ahead and put it out.
It really is, because nothing is really using SSL nowadays, right? But it's like the historic, we went through 3 layers of SSL, and now it's all transport layer security and TLS certificate. Yeah, exactly.
Great. I am historic.
Right. And, I've got my fair share too from many, hey, this cert's going to expire in a day and we have no idea how to install it on the load balancer. Good luck.
So I guess I'll use that as a transition, or as our segue into, the show. So this is Ask an OpenShift Administrator. This is one of our office hours series of shows or of live streams here on OpenShift TV. So our goal with these shows is to have a conversation with you, with our audience. Please, at any point in time, ask us questions across any of the various platforms that you happen to be watching us on. Your questions will get rebroadcast to all of the others, and we'll address those as they come up. Mm-hmm. So in the lack of questions, and also to help focus your questions, we do have a topic every week. As I said, this week is around certificates and how they're used, some things that you, the administrator, should be aware of inside of your OpenShift cluster. And that, of course, is why we have Brian here, because Andrew obviously does not know what he's talking about when it comes to this topic. Before we get started, though, as is custom or customary, I guess. At this point, we're what, 32, 33 episodes in. I try to do this every
32,
episode.
yeah.
So I have some things that are top of mind. Effectively, these are things that I have seen either internally or externally that I feel are relevant to you, our audience. And I tried to bring up, ranging from security advisories, right, that might be important, to just other things that are going on. So the first one of those that I want to talk about is something that I was tangentially involved in, mostly just as a reviewer. And that is particularly for our VMware customers, so OpenShift on VMware. They recently released a new reference architecture. So I'm going to share my screen real quick here.
Oh,
Just as soon as I find the right window.
I believe in you.
This is always an issue.
Right. There's no consistency when you hit that share screen button. You have no idea what's going to happen.
Yeah. Why can't these show up in the right order? And by the right order, I mean the one that I want them to be.
What's logically in your head? Yeah.
Yeah. All right. So let me grab this link and I will post it into the chat.
Thank you.
So this is a reference architecture published by VMware for running OpenShift on VMware Cloud Foundation on Dell EMC VxRail hardware. I know that's quite the mouthful. So essentially, it just walks through all the different aspects of how to deploy, how to use, kind of some considerations, the testing that they did for OpenShift on that stack of technology inside of there. So if you aren't familiar with the whole VMware Cloud Foundation thing, right, it's the integrated stack of using, what do they call it? The Cloud Manager, VMware, I think it's Cloud Manager, something like that, to do automation around deploying vSphere, including ESXi, vSAN, NSX, right? All of those things. Whereas the administrator, you go in and say, I want to deploy a workload domain, and then you go in and you deploy OpenShift on top of that. And that is in combination with, there's also another reference architecture, if you didn't know about it. Let me dig up that link. So they also have an SDDC reference architecture. So I'll post that one in here too, or post it there, and then post it here. Yes, Twitch. I know that animated emotes can be disabled.
It's been so annoying with that message lately.
So you can see this one. I think there's a newer version. I need to update my link. It was updated last year, almost a year ago, actually. So I think there is a newer version of this out there. But just FYI, right, if you are a VMware customer, if you are looking for reference architectures, this is the place to go for those. So kind of bigger picture, you'll notice that Red Hat has not produced any reference architectures for OpenShift on X or Y or Z since roughly the 3.10 timeframe. So the rationale for that is we rely on our partners to do that work, right? They know their hardware, their software, their infrastructure, whatever it happens to be, better than we ever could. So we help them with the OpenShift part. They do their underlying part, and then they post that. And I bring all of that up because, and let me see here if I can find the right window. Because there is a blog post that talks about all of these. So
there's a lot of duplication of effort, if I recall.
So, and this one I will post down here as well. So this blog post, you can see it's a year old now, but it actually does get updated. For example, last week, they just added this NetApp reference architecture on here. So it does periodically get updated. But this is one place where you can go to find all of those reference architectures for the partners. Brian, I don't know the precise process associated with it. I know that there's a team of folks, Dave happens to be one of those team members, or at least he used to be, that are responsible for working with partners and doing that, joint effort, the review and stuff like that. So I don't know the precise details, but yeah, it wouldn't surprise me if there's a little bit of redundancy inside of there.
Yeah, well, that's one of the reasons why we're having our partners do it rather than have us provide one and our partners create a duplicative one outside of Red Hat. So leveraging that relationship and letting our partners inform us the best way to do it on their platform rather than little bit of a back and forth makes that a lot easier.
Yeah. And I also can only assume, I have 3 kids. So if I do something for one of my children, the other 2 are going to want the same thing.
Right.
Right. And I can only imagine that if we create a reference architecture for a partner, then all the others are going to say, well, why didn't you do that for me? Whereas we can work around those types of conflicts of interest, if you will, by simply asking the partners to create and maintain those. So anyways, so if you are curious, that's why you don't see Red Hat publishing reference architectures. You see them coming from our partners. And if you do have questions like, hey, where's this? Does this partner have a reference architecture? Feel free to reach out to me. You can reach out, email andrew.sullivan@redhat.com or social media, Practical Andrew on Twitter. All right. The second thing I had here. So we talked about when Tushar was on the stream, gosh, a month ago now, maybe 5 weeks.
Wow.
Excuse me. We talked about how the Red Hat developer entitlement. So if you go to developers.redhat.com and you register for an account on here, right? So if I were to go to login and request an account and all of that, you receive a Red Hat developer entitlement, right? You can deploy up to 16 nodes of RHEL, so on and so forth. And all of that is free, right? We don't charge for that. OpenShift is included in that. However, at that time, we discovered that there was an error where it doesn't actually show up. So if you register for your account here, and then you go to cloud.redhat.com/OpenShift and deploy your cluster, and then it shows up in Cloud Manager there, you wouldn't actually be able to entitle it with anything other than the 60-day eval. So I think that's fixed. I haven't actually validated. So if it's not there and you're trying to do that entitlement, just be patient. Let me know, and I'm happy to associate with the internal workings that you're having issues. But it is something that is supposed to be there, and all of that. And if you are curious about, hey Andrew, how do you know that that's there? So we actually have a thing called Appendix 1. I won't dig up the link because I don't know where it's at the moment, but I'll include it in the blog post. But we have a thing called Appendix 1 to the entitlement legal document that includes a specific description of like what all is included in that, and OpenShift is explicitly in there. All right, and I know all of this because we got asked internally. One of our field folks said, "Hey, this isn't working. This isn't here." So the last thing that I have to talk about is something that comes up semi-regularly. So back on the VMware side of things, we've gotten asked a number of times about, hey, can I deploy OpenShift and use SRM, VMware Site Recovery Manager, for disaster recovery? Or can I protect, this is one that was asked yesterday, can I, with 2 sites, can I span a cluster across those 2 sites and use VMware fault tolerance to protect one of the control plane nodes so that it's kind of at both sites at the same time, right? And the question was specifically, is this supported? And the answer is yes. If you're using SRM, if you're using FT, it doesn't invalidate support. However, the bigger question is, do you really want to do that? And I say that because not that there's anything wrong with fault tolerance, but fault tolerance comes with a performance penalty. It has specific requirements. It has specific needs that are not insignificant. I did a quick Google search or DuckDuckGo search the other day, and it was something like an anecdotal 50% performance penalty. Just out of the box, 50% performance penalty. So for etcd, which is something that is already performance sensitive,
very performance sensitive.
Yeah, having, okay, even if it works, it probably will work if you can meet the requirements. You're going to be, severely limiting your scalability of the cluster and stuff like that. And, we talked about etcd in depth during that episode. I'll try and remember to include a link to that when I talk about this in the blog post that'll go out Friday morning. But just, yes, you can use that. No, it won't invalidate support. Just be sure to be ultra aware and be prepared for any ramifications of that decision. So yeah, that's all I got. Chris, Brian, anything?
I'm just following along with the chat here. a little bit.
Yeah.
Oh, I'm glad somebody
So
is, because I've lost track of it.
that's quite all right. Saw one of the questions was whether or not there was a difference in the self-signed certificates in Red Hat OpenShift container platform from other certificates you might need to use to configure your cluster. Functionally, the certificates are no different than standard TLS certificates you might get from a certificate provider. It's the usage of the certificates and the number of types of certificates that are in use, the purposes. Essentially, if you go to a CA externally, you've got certificates to identify servers, certificates to identify clients, code signing certificates, other certificate purposes. The list is longer than I can remember off the top of my head. OpenShift does use mutual TLS or mutual authentication between client and server. So when the client wants to talk to the server, it checks the server certificate to ensure it's talking to a trusted server and presents its own certificate so that the server knows it's talking to a trusted client. And that's not any different than any of the other certificates, the way they work in practice. But externally, consumers work with the API or with the web console, the CLI. Those certificates by default are generated from an internal CA, and we routinely replace those with something that's signed either by a public CA or an enterprise CA within an organization. So that kind of leads into some of the other questions that were asked here, like self-signed certificates used at all externally? Well, by default, yes, until that cluster has been configured with those certificates.
So, Brian, if you don't mind, I'm going to interrupt you because I want to reset a little bit. And
All right.
as my 13-year-old reminds me constantly, I'm a dumb guy, right? So, is there? I guess so. In my understanding of OpenShift, there is effectively, I think, three primary things or three things that I know we use certificates for off the top of my head. Right. So the most obvious one is the certificate that the ingress controller uses for external communication. Right. So here I'm still sharing my window. So when I browse to the console here, the certificate that this uses is signed by that. Let's look at this. Right. So it's signed by this ingress operator right here. So that's one of those instances. If now there's others where it's, I think, node to node communication. So for example, the control plane talking to worker nodes. And then there is pods talking to pods. So if a pod is using, if it's encrypting its traffic, it's using those internal certificates. And I know that some of these things change based off of like the route policy, right? Is it, re-terminate? Is it pass through, that type of stuff? So if you don't mind, can you kind of level set all of these things? First of all, please, of course, correct me and tell me where I'm wrong.
You're not wrong at all in any of this. The service signing certificates that can help encrypt pod-to-pod communication, I'll go ahead and say that's not really automatic. The certificate issuance is. The trust is provided by CA bundle that's provided to the container, but the application needs to be aware that those secrets have been generated, mounted on the pod, and that there's a CA trust bundle that's been exposed to the pod by Kubernetes itself. So I'll say it's not transparent unless one is using something like service mesh to wrap the pod for encrypted pod-to-pod communication, using the service signer certificate to sign the services or to provide pod certificates automatically within the platform. That requires a little bit of user interaction, but I probably digress. One of the things I like about OpenShift is that one need not concern themselves with a lot of what's going on with the internal certificate, CA, the signing process. There's so much automation in the platform that it's typically sufficient to say that all of the communications is encrypted except the application communication by default. That ends up being a responsibility for customers to turn on and manage and choose how they're going to manage that, whether they're using the service mesh operator and configuring that with or without enterprise certificates, or whether or not they're going to use the OpenShift router to terminate, and if insecure communication within the cluster is acceptable, that's an option as well. I'll go ahead and stop and see if you've got any more driving points, clarification.
And that's, so you're talking about, so service mesh there wrapping that traffic, but that's different than, for example, at the SDN layer. And when we had Mark Curry on, we talked about the IPsec configuration with OVN Kubernetes. That's all handled a layer below the pod to pod traffic or communication, right?
Absolutely. And it's interesting you brought up IPsec, because that's not one of the things I have really thought about too much in recent times. In OpenShift 3, we could configure IPsec on the SDN using standard Red Hat Enterprise Linux packages and conventions for encrypting that traffic node to node. The pod-to-pod traffic in that particular case is not encrypted. We're just encrypting the transport layer on which the pods are communicating between each other. But with IPv6 integration, that network encryption comes along with the feature, and it's available for use with IPv4 traffic as well. While it does use TLS TLS in order to establish and maintain the encryption, it's not TLS in the same way that we're generally talking about with client browser to server type traffic or pod to pod traffic.
Okay, so just to make sure I'm understanding, IPsec at the SDN layer happening below the pods, they're basically unaware of it. I'm an old storage admin, right? So my brain, this is the equivalent of like encryption happening at the storage system. So it's encrypted at rest versus encryption happening between the client and the storage system, like in transit, versus the application encrypting and sending it. So yeah, there's different layers inside of there, and each one of those is possible, right? Translate over to the network traffic realm. Each one of those is possible. It's just implemented in a slightly different way depending on where you're looking at.
Absolutely, and there's a nuance to that. If I'm encrypting at the SDN level and I'm not encrypting at the pod level, some of that pod communication may be in clear text between two pods if they happen to be on the same node. And even before they leave the node, before the pod traffic gets encrypted by the SDN, that could be inspected on the node as well. So,
okay, so that could have ramifications from a security posture, from a auditing type of perspective.
Absolutely.
So I'm going to jump over to chat because I see that there's a couple of questions in here, or comments/questions around Cert Manager. So Cert Manager, as I understand it, is a third party. I don't know if it's an operator or so much as a deployment. I think it's a Helm deployment.
Yeah.
For creating basically trusted certificates from, if I remember correctly, it's Let's Encrypt, right?
Mhm.
Automatically. So essentially you create a route and it takes action to request from Let's Encrypt that certificate, and then it uses that certificate with the route so that, you know, as you see here in my browser, right, you don't get this not secure, right? You're not using a self-signed certificate that you have to manually trust. It automatically shows up as green. So is that accurate?
That is pretty accurate. Last year, Raffaele Spazzoli, one of my associates, did a blog post on that. I linked that. Oh, I made too many comments on that document yesterday. So that is one of those things. Yeah, that's exactly the article I'm talking about. He's got a YouTube
Nicely
video
done.
on there where he does step-by-step walkthrough of that. It's 2 years, nearly 2 years ago. That's last year. So that's been available for a while, and that's one of those things that not only does it work with Let's Encrypt, but it could also work with other CAs, such as an enterprise CA. I've heard of few people using that to talk to Identify and other solutions, but I don't have a full list of everything that's supported. But yeah, this is one approach using the operator deployed via Helm chart in order to manage the certificates for particular routes. There are possibly other layers in which this could be employed, although typically the route layer is the safest. If I start working up toward other components in OpenShift, I introduce potentially more risk.
Got it.
But for application traffic, this is one way of doing it. The other way, not talking about external routes, let's say, but internal route communication. Let's say I've got a certificate that's been issued by a public authority and I attach that to my ingress controller. I could use what we call re-encrypt. It's actually an edge termination with the re-encrypt on the back end so that I could use the internal service certificate signer with an OpenShift, and customers will only see that front end certificate. And then the rest of the certificate management is done with internal certificates inside of OpenShift. Very similar process to doing that, but employed at a different level. If I want pass-through, though, and there are a lot of reasons to use pass-through, doing re-encrypt is going to strip some of the information off of the traffic. If I need mutual TLS, if I've got no trust network infrastructure where everything's going to be authenticated using certificates, I may need pass-through. In that case, having a certificate signer using Cert Manager on the application rather than using the internal certificate signer would allow me to get that additional information through the connection.
Got it. So it really depends on the trust side of things so TLS, if I remember correctly, has like the SNI. If you need that SNI to reflect specifically that application, then you would want to use pass-through as opposed to re-encrypt.
Correct. Now, there are reasons to use re-encrypt as well. If I'm doing any type of path-based routing, or if I need some information annotated by the OpenShift ingress controller, the load balancer, I would need to have headers be modified by the router. I would need the router to be able to read the path in the request. TLS 1.2 has that wrapped inside the encryption packet. But if we look at newer versions of TLS, OpenShift supports TLS 1.3 right now. They support encrypting the headers separately from the data. So one can possibly use edge termination re-encrypt with TLS 1.3 without losing any functionality. But it depends on which version we're using.
Got it. Hopefully you weren't able to hear all the banging of the garbage truck coming by.
No, didn't hear it.
Okay, good.
Hopefully you didn't hear the lawnmower that just went by at my place.
I know. It's Wednesday's a busy day, I guess, for public services. So I'm trying to catch up on chat here.
There's a lot of questions.
So do we plan recordings about a deep dive into Cert Manager? So we don't have anything planned at this time, mostly because it's a third-party thing, and we don't tend to focus on those. As Brian pointed out, Raffaele did do the blog post, and I know there's a YouTube video associated with that. So if you're interested in more information there, reach out to me or Chris, or both of us. Shoot us an email, and we'll reach out to any relevant folks and see if they're willing to volunteer, either to come on a stream or to potentially update like this blog post if it needs to be done, since it's almost 2 years old, as you pointed out, Brian.
Yeah.
What is the actual use of kube API server to kubelet signer in OpenShift 4? Is it something like the certificate authority used for MTLS communication between API to kubelet?
Oh, so when we're talking about the API server to kubelet signer, We are indeed talking about the node signing certificate. There's a little bit of automation when we deploy a cluster that's going to automatically approve all of the certificates required for the control plane. But typically, we admit the nodes if we're doing a user provisioned infrastructure type deployment. The installer provisioned infrastructure will automatically handle that, so you don't have to worry about it. Along with machine set automation. Wow, it does get a little bit more complicated now that I think about it in context. Once nodes have certificates, those certificates are very short-lived, like 4 hours. So there's a constant process of certificate renewal going on in an OpenShift cluster. And some of these processes, services, operators, they handle the evaluation of the requests coming in, the validity of the credentials that are requesting new certificates, and handle the certificate signing and reissuance in the background. Node operator factors in here pretty heavily. I don't know how involved the machine config operator is in this, but
so that raises two questions for me. So as you said, when we do either non-integrated or a UPI install, a human has to approve those certificate signing requests. So first question is, what is the purpose of that CSR? And I'll say my layman's answer to that is usually, well, that's somebody saying, yes, this is the node I expect it to be. And then the second and kind of follow-on question is, we see a lot of times customers have issues when they shut down their cluster for some period of time.
Mm-hmm.
And when it comes back up, the only
Bump.
action that you need to do, that's with the wink, wink, not always only, but usually the most visible one is you have to reapprove CSRs for the nodes to come back. So what's actually happening there?
yeah, so that's a 4-hour approval that I was talking about, the 4-hour validity time of some node certificates. It varies depending on what certificates. I'm not sure if the client and the server have two different lifespans or if they are both issued for 4 hours. But a lot of the certificates we have are valid within 4 hours at the shortest and 30 days at the longest when we're talking about this level of certificate. Sometimes we can survive cluster being shut down for a weekend. For example, if it's a lab cluster and we don't want to burn too many hours, or if we want to relocate hardware from one part of a data center to another part that requires downtime. But you're absolutely right. If those nodes have been down for too long and we're within that period where the certificates need to be renewed, they can't request, and a CSR is a certificate signing request where I say I need a certificate for a particular purpose, and I send that request over to a certificate authority. If my credentials can't be validated, if my credentials have expired, my CSR won't be automatically approved, which is where an administrator may need to go in after somewhat of downtime of the node and look for certificate signing requests that are in the system. And as an administrator, sometimes we could be a little bit lazy. If we know we've got a whole bunch of certificate signing requests and we don't expect any malicious requests to be sent to our cluster, one of the things we may just go ahead and do is approve all of the certificates all at once. It's kind of bad practice. Good practice would be to actually open the certificate signing request, validate the source of the request, and ensure that's one of the nodes that is actually part of the cluster, and then do the approval. Once the approval hits, the cluster will go ahead and handle the issuance of the pending certificate, and the node will pull that down. If one waits too long, and this is something that I've seen pretty commonly, cluster gets shut down for a period of time for some sort of maintenance activity, and then it's brought back up. All the nodes will send their CSRs at once, but the system won't hold on to the CSRs forever. The CSRs will expire after 1 or 2 hours, and then I might get a call, hey, my clusters down. I'll say, are there any pending certificate signing requests? And they'd say,
and
no,
there's
I
hundreds of
looked. Yeah, either there's hundreds of them, in which case I've seen somebody actually go through 200 requests one by one and approve each one of them. It
Whoa.
actually,
That's
oh my
someone who's
God.
paid by the hour.
Yeah. We've got a long command that'll actually look at all the pending certificate signing requests. It's probably 2 or 3 lines in the documentation. I hate that one because it's long. I can't memorize. I just type OC observed CSR
I'm going to paste it
dash
into chat.
OCADM certificate approved.
There, I pasted it into the stream chat.
Oh yeah, I'll go ahead and type in my shortcut here.
So I'm there's a 4 or 5 questions in here. I'm actually going to go a little bit out of order. So Krishna, I see your continuation. We'll get to that in just a moment. And John, thank you. Happy to host the topic. Christian, I also see your question there. So let's, and this is, I'm not even going to attempt to say DMI 3. So let's assume that we install OpenShift 4 in a test environment or a lab. Can we extend the lifetime of those certificates, say, to a year or more, basically, so you don't have to worry about that whole, it expired, I need to go in and manually do something process? And I don't know.
So. I don't think so.
Yeah.
Or was that for me? I was typing.
Oh, you're fine. Yeah, can you extend the lifetime of node certs, or is there a functional, easy way to do that? Semi-easy.
So one of the things I tell people quite frequently is if it's not in the documentation, it's not something that is recommended or supported. The short answer is you could do probably anything you want to do if you know which operator and which configuration, or modify the images, for example. But the short answer is no. And why? Why would we want to do that? Obviously, administratively, there are purposes for it. Might want to shut down a node over a weekend for maintenance and not have to approve the certificate request when it comes back up. It's administratively convenient. But the impact it has on security can be potentially high, and customers are often risk averse, both in terms of unexpected downtime, but also in terms of security. What happens if a certificate and key gets leaked outside of the environment? Somebody gets access to the node and uses that certificate elsewhere. What damage could they potentially do? So short certificate lifespans factor into some of the security decisions.
So I want to take a moment here because in Pram, shortly I'll be taking holiday and turn off the home lab cluster, and basically we'll live in fear during that time, because the last time he did this, he had to redeploy the cluster. And I think it's important to point out that, at least for me, and I do this all the time, right? That exact scenario of I always have somewhere between 1 and 5 clusters deployed in my lab, and I turn them on and off constantly. I'll be going on PTO in a couple of weeks. They'll be turned off the whole time, right? So you want to make sure that your kube config, or your kube admin config, right? So the one that gets created when you do OpenShift install. If you don't have that, you want to generate a new one. There's a KCS for that. I'll dig it up in just a moment. But you want to make sure that you have that. And then when the cluster comes back, and by back, I mean, it's powered on, but it's not actually running, you use that kube config to connect as the system admin user and reapprove those CSRs. So, and Brian, where I'm leading to all of this is I've also seen anecdotally internally, some folks say, well, that doesn't work because the API server isn't running because the certificates aren't valid. So how do I work around that? Personally, I've never experienced that, and I've left clusters off for months at a time. And it comes back up, and I reapprove the CSRs, and 10 minutes later, the cluster is back to functional. So is there anything else?
So I've had the same experience myself, where I've shut down a cluster for 30 days and more than 30 days and brought it back up, and the control plane came online without a problem. There is a difference in terms of the certificates that are on the control plane servers and the certificates that are on the workers, and that the control plane is locally privileged. etcd is local to each one of the masters. The certificates that authenticate etcd to etcd, those are maintained outside of the data store so that the data store could be brought up without any problems. And the services, the pods that are running on the control plane nodes do have direct access through that to do their own certificate approval. There's not really an issue there. The nodes may have to be reapproved. That can be automated. We actually had a node auto approver pod in an earlier version of OpenShift that I haven't seen in OpenShift 4, but it's essentially where some of our code snippets and some of our administrative shortcuts, or the snippets we could remember, come into play. In practice, I haven't seen a problem with being able to shut down a cluster for a long period of time and be able to bring it back, except for one case. And in that particular case, I messed up on the DNS server.
Ooh.
So the reason things weren't joining the cluster properly was because my DNS server setting was wrong. It's embarrassing.
Okay, so I'm going to jump back up to those earlier questions that I mentioned before. Let's see, where did they go?
Hey, scroll up.
No.
You want me to ask them? You want me to handle it? Like I can.
So a continuation from so Krishna, who asked before, what is the actual use of kube API server to kubelet signer? So node certs, so the server-client.pem files, are signed by a different CA, specifically kube-csr-signer _ random numbers. And for MTLS, we think we need to have the same CA for peers. I couldn't see any cert that is signed by kube API server to kubelet signer. So I think where you're going with that, I think the question here is more or less, because that specific CA isn't signing the or isn't signing all of the certificates, using SNIs or TLS 1.3 means that it doesn't, or if you want to use TLS 1.3, it doesn't work the way as expected. I think. I will admit that I am speculating there because this is not my area of expertise.
So I believe this may be a good time to bring up the number of CAs that are in OpenShift.
Okay.
And this I linked directly to a comment. So I don't know if you see that, and where the certificates came from to the OpenShift blog. So one of the things that we might have, and I don't know if you want to navigate there, or
is this the considerations on OpenShift PKIs and certificates?
Yes, that's the one. I've got a comment half typed in that I was going to send that I didn't want to mix that up with. So PKI has the, or public key infrastructure has the ability to have a CA that is the ultimate trust for everything. And underneath that CA, I could have several sub CAs or intermediate certificates. And those sub CAs can also be certificate issuers if they have the issuance flag enabled on them. In OpenShift, though, instead of having a single root CA, we actually have 4 root CAs. And the purposes of those 4 root CAs are for the platform, for the aggregator proxy, etcd, and for the service signing. Now, I think I lost my thread here, what the question was and which direction, but
more or less, is there a conflict because certificates are signed by those different CAs, and does that cause issues for I think pod to pod communication?
So no, and the reason I would say no is there's two bundles that are provided to the pod. One bundle has all of the relevant certificates that a pod may happen to encounter within the cluster, from pod-to-pod communication being signed by the OpenShift service signer, for example, or pod to API signed by the platform CA. Those are in one bundle that should be automatically trusted within the pod. If it's not automatically trusted, let's say we've got an application that's using its own key store trust bundle, that can be chained into the pod either with an entry point script or by pointing the application to where that CA bundle happens to be. And there's also a client CA bundle for any other certificates that exist within an enterprise, for example, that can also be used. There are two bundles that are provided underneath that mounted secret. Now, none of the information in those CA bundles are secret, by the way. It just happens to be a secret object in which we communicate that to the pod. So that's of some note. Where that's located in the pod, I don't remember off the top of my head, but I think it's like varlib Kubernetes.
Let's see if we can find a pod. We'll pick a random one of these.
Yeah, and one won't see that in the pod spec. It's something that's mounted outside of the pod spec. Kubernetes just adds that to the containers by default.
Maybe var service? Maybe not.
No,
so here we've got the service CA underneath var service CA. We've got the trusted CA, because these are all volume mounts that it's pulling in.
There you go. var run secrets kubernetes.io service account trust bundle is under there. I didn't know it would actually show up in the spec like that, unless it's.
I'm assuming this is because it's a running pod.
Yeah, I'm assuming the deployment had been modified when the pod was instantiated.
Yeah. So I'm going to take a slight detour here, because I was just reading through chat and I saw the command that you use, the OC observe. I didn't know about that subcommand. That's a new one to me, and that one is awesome. I'm now going to start using that. So if you're not familiar with OC observe, do an OC observe -- help. And it's exactly as Brian showed it being used. It looks for something and then takes action. It basically passes that through to some command. I did not know that. Thank you.
Yeah, me either. That's a good one.
Let's see. So just digging through chat here. I thought I saw a question from Christian up here. If I'm doing re-encrypt, do I need to provide the router's certificate in my route config?
So we've got a new way of doing a secret reference in the route configuration. So the certificates don't actually need to be in the route object. They could be referred to as a secret.
They can? When did we change that?
I believe so.
That was one of the big complaints a lot of people had of, if I want to use my own certificate with a route, it has to be defined in the route. I can't put it in a secret. And for a long time, my response was, but secrets are no more secure than a route.
Well, yeah.
And that's kind of interesting too, because I looked at the potential of encrypting the route objects back in my OpenShift 3 days, and found that one could specify all the objects one wanted to encrypt, like secrets, config maps, and routes. But only secrets and config maps would actually get encrypted. The route definition in the encryption config would be ignored. So the routes were definitely not encrypted. The best place to validate that would be in the API documentation for the route API object. Taking a look at that, unfortunately not on the screen share.
I can dig it up.
I always hate doing a dig through of the internals on a call.
No, that's totally acceptable here.
So certificate provides the certificate contents, authority contents. Thought we were able to do a reference to a secret in here. I may be mistaken.
That's okay. I'm hopeful that we will change that someday.
Yeah.
Yeah.
If nothing else, because it's a check in the box. I don't know. Andrew's personal opinion is that I don't know that there is significant value to that, but I do understand why some people want to have that separation.
Well, and there's another reason too. It's not just separation. It's being able to share what the pod is seeing and the service is seeing with what the route is exposing to the OpenShift router. Now, in fairness, one of the reasons for not having this be a secret, and this is somewhat historical, one can't read secrets between two different namespaces. But recently, we've had the ability to use exported secrets, somewhat of a projection of secrets, where it is visible from other namespaces. So it looks like it just hasn't made its way, but the OpenShift router needs to have a copy of all the information. So even if it was stored in a secret rather than in the route object itself, it would still need to be communicated to the OpenShift ingress so that the router could present that certificate and authenticate to a client that it is the server that the client expects. So we can't hide everything. It's not possible to hide all of it because we need to be able to actually use it in these other objects.
Yeah, at some point you have to trust that RBAC is doing what RBAC is supposed to do.
Right.
So there's, I see three questions here.
I got a lot of questions if you got time.
So what are the best utilities to use for debugging issues with certificates?
I mean, OpenSSL is a great tool. Curl is a great tool as well, if like it's actually applied. But
you can, if it's at the node level, you can debug into the node and access those resources there. You can also, connect to the pod. So open the, here, if I jump over here, if I go to the terminal here, I can look at all of the mounts inside of here, and you can see, all of the, here's exactly what Brian was talking about a moment ago, right? That's where you'll be able to see all of those things inside of there. Some pods, of course, won't have those tools inside of there. You can always copy that file out and then do some analysis on it. And as always, all of these things are controlled by operators. So if you, and here, let's come all the way down to administration and cluster settings and cluster operators. So you can always go into the various operators and look at their logs. They'll surface up high level information and you can go in and then dig into various things. And one of the things that I like, your related objects. So this related objects definitions, and it shows you the same exact information if you do an OC get CO. This is a great way to figure out like, oh, I know it's something with the name server, but I don't know where name server puts all of its stuff. Look at this related objects and it tells you it's, or a kube API server, right? Oh, it puts stuff in this namespace, OpenShift config manage, so on and so forth. And then you can click inside of there to find out. Brian, anything to add?
One of the things I've noticed is OpenShift will reject some configurations that it deems to be invalid once they're applied. So some of the troubleshooting on the OpenShift basis isn't always necessary, although OpenShift does allow some certificates to be replaced. Like if I replace the API or the ingress certificate, it would deem those to be valid in and of themselves. But if I do them out of order with the documentation and my login expires in between, I may not be able to authenticate back into the cluster because now I've got a mismatch between the trusted certificate for the OAuth server, and the API server. There are ways around that, so it's not necessarily a a fatal operation to do, but order of operations definitely matters there.
Yes.
As far as troubleshooting certificates, often these are done from client-server basis. OpenSSL S client is a very good invocation of the command. It could be used with -so certs to show the certificates of the client or the server, and -connect in order to specify the host and port. There are a few other options. One of the things to note is OpenShift is very heavily based on server name indication. Essentially, the host header needs to be outside of the encrypted packet so that other services know which certificate to present back to the client and know which service on the back end to route that traffic to. If there's a mismatch in SNI, there may be inability to connect with the application in the back end. I've seen this quite frequently, especially with older clients that don't pass SNI information properly, or even some misconfigurations. I've seen an SNI packet incoming into OpenShift, and I had to use TCP dump in order to see this. But the SNI header was actually requesting a host name somewhere else out on the internet. I don't even know how that was being directed to the cluster, but the host name did not match anything that should have been in that environment. So there are levels where things can go wrong that aren't necessarily the fault of the certificate, the way it's issued, the way it's signed, but in just the way the client's communicating with the server and how server name indication works. Order dependency, TLS 1.2 specifies that the intermediate must become before the certificate. A lot of clients are very lax on this, and they'll take the certificates in any order and go ahead and say, yeah, these are related, and this is the order in which they go. But some clients are strict. And if the client certificate comes before the intermediate, it'll be rejected. And this often can be a little bit of a head scratcher when every other troubleshooting command succeeds, but the connection still fails. So the list is pretty much non-ending of things that could potentially go wrong with certificates. Most often, the problems I see are related to application communication. The platform certificates are pretty solid, pretty well automated, and one just has to make sure that any enterprise or external certificates that are provided for the API and the ingress controller are not expired.
Got it.
The SAN, subject alt names, something not to be ignored. Sometimes it's good to have multiple things specified in a SAN for the wildcard certificate. Like if I've got a host that's serving, say, US and Japan, and I want to host applications that could respond to either .com or .co.jp, I may want my SAN to have multiple top-level domains listed. Just so if I get into a point where a pod's down, application's down, I don't get a TLS certificate error because suddenly the default wildcard certificate is answering instead of the intended route. So
I think we've got maybe 2 minutes. Chris, do we have a hard stop today?
You have a 30 seconds, and yes, we do have a hard stop.
Okay. So I won't ask either one of these last two questions. Instead, we'll address those in the blog post. So I'll take these last few seconds to thank Brian very much for joining today. Your expertise has been immensely helpful. So thank you so much for joining. To our audience, thank you for participating. These questions have been phenomenal today. So I will be sure to follow up in the blog post. It will be out Friday morning with all of that information. So keep an eye on openshift.com/blog. And I will see everybody next week. Thank you so much for joining us today.
Thank you so much.